Hello friends, this is Wael Bashuri, math and physics teacher. In this video I'm going to solve this online physics quiz for grade 10 in Qatar and for grade 9 in other countries. Question number 1. Which statements are true about the acceleration due to gravity? Select all that apply. It can be measured using a ticker timer. Yes, that's correct. It is directed vertically downwards. Yes, this is correct. Unit of acceleration due to gravity is in Newton per kilogram. Newton times kilogram. This is incorrect because the unit is in Newton per kilogram, not times kilogram. It varies depending on the mass. No, it doesn't change because it's constant, which is 9.8 meter per second squared or Newton per kilogram. It is the acceleration at which all objects free fall down the earth. This is correct. Question number 2. Which statement about gravitational acceleration G are true? Select all that apply. First one, its magnitude decreases with altitude. Yes, this is correct because whenever you go higher, the gravitational acceleration decreases. It becomes equal to 0 when the distance becomes greater than the radius of the Earth. This is also true that change in G over sorry, this is incorrect because G approaches 0 only at very large distances, like when we say at infinity. So this is outside the Earth's surface. So this is false. Its magnitude increases with the mass of the planet as the mass of the planet decreases. This is false. It's practically constant over few hundred meters above the sea level. This is correct. Its magnitude increases with altitude. This is wrong. Question number 3. Which components can be used together to experimentally measure a gravitational acceleration? Select all that apply. An electronic stopwatch, yes, can be used with a falling object. So you can drop from a known height and then measure time, and then you can use equations to calculate G. Strobe photograph, also yes, multiple images of falling object at equal time intervals can be used to find displacement between frames and then compute G. Spring balance, no. Ticker timer, also yes, attached to a falling tape to make it makes dots at a fixed frequency, giving time and displacement data for calculating G. Speedometer, no. Question number 4. A box is pulled with a force F on a rough incline making an angle 30 with the horizontal as shown below. The box moves with a constant speed. Fill in the blanks. The acceleration of the box is equal to what? Since we're saying to you here constant speed, this means the acceleration is 0. So whenever you see constant speed, acceleration is 0. The box is said to be in equilibrium whenever the acceleration is 0 or constant speed or stationary, we say equilibrium. The behavior of the box is predicted by the principle of inertia. Question number 5. A box of mass 3 kilograms is pushed on a rough surface with a force of 8 newtons as shown below. The resistive forces opposing the motion of the box is 2 newton. Fill in the blanks. The horizontal component of the acceleration of the box is equal to what amount? Here we apply Newton's second law of motion. F net is equal to mass times acceleration. F net mass times acceleration. So box mass 3, so 3 here. Acceleration we don't know. The resultant force acting on the box is 8 to the right, 2 to the left, so 8 minus 2. 6 equal to 3a. A is equal to 2 meter per second squared. So here, horizontal component is 2. The vertical component of the acceleration of the box is 0 because the resultant force vertically is 0. So if you plug 0 here, 0 is equal to mass times acceleration, divide by mass both sides, 0 by 3, you get acceleration equals 0 vertically. Question number 6 now. Fill in the blanks with the terms from the box below, drag and drop. The gravitational field strength of the Earth is the per unit mass. So here we put the force per unit mass at which Earth pulls all objects downwards. So here downwards. Question number 7. The acceleration due to gravity is the same as gravitational field strength of the Earth. Question number 8. Drag and drop the mathematical expression in Newton's law of gravitation. This is G m1 m2 divided by r squared. So this is easy. Number 9. A particle is at a distance r from planet A of mass m and gravitational field strength Ga as shown below. The same particle is then placed at an equal distance r from a planet B of mass m and gravitational field strength Gb. Match each condition on the masses to its corresponding statement. Now, according to the formula given from Newton's law of universal law of gravitation, force is equal to G m times m divided by r squared. We can write here mg is equal to G m divided by r squared. We can cancel m and m, and then we find that the gravitational acceleration is G times the mass of the planet divided by square of distance from the planet. Now, here you can easily notice that G is directly proportional to m. When G increases, m increases. When G decreases, m decreases. So, when the mass is 2m, the gravitational acceleration will be 2g. So, this and this. When m is 0.5 m, the gravitation will become 0.5 g. GB, GA 0.5 GB. When the masses are equal, the accelerations are equal. Now, question number 10. The gravitational field strength in deep space can be considered 0. Number 11. A motorcycle of mass 300 kg is moving along a straight track with a velocity v equal 40 meter per second. When the rider hits the brakes, a resisting force of magnitude 2 kN is applied. Neglect air drag. The bike comes to a stop in what time? We know that force is equal to mass times acceleration. Force equal ma. First step, I need to calculate acceleration. Acceleration is equal to v minus u over t. Since it stops, velocity final will be 0. Velocity initial is given to us as 40 meter per second. And the time, we don't have it. Comes to the bike comes to a stop in what time? So time we don't have it. So let's calculate acceleration from this formula. The resultant force acting on the rider is 2000 newtons. So 2000 newtons. The mass is 300 kilograms. The acceleration, we don't have it. So the acceleration would be, in this case, 20 over 3. Now you plug 20 over 3 here. So the acceleration would be, you plug 20 over 3 in acceleration. So plug it here. 20 over 3 is equal to negative 40 divided by t. Now if you cross multiply, you get 20t. Of course, this must be minus because the force is resistive force, or acting backward, opposite to the motion. So now if you cross multiply, you get negative 20 times t is equal to negative 40 times 3, negative 120. 3 times 4, 120. So now divide by negative 20. T is equal to 120 divided by 20, which is 6 seconds. So here the answer is 6. Question number 12 now. 5 kilogram box is placed on a table. Select the equation that relates the mass m of an object to its weight. W is equal to mg. This is very easy. Knowing that the gravitational field strength is 9.8 meter per second squared, what is the weight of the box? Choose the correct answer. You do W equal mg. So the mass is given as 5 kilogram, and gravitational acceleration 9.8. We multiply them and we choose the answer. Now question number 13. A body is free falling near the surface of the earth. What can be said about the body's acceleration or the body's acceleration? Choose the correct answer. Here we say it's constant. The acceleration is constant because it's near the surface of the earth. Of course, neglecting air resistance. Question number 14. 1200 kilogram car initially traveling at 25 meter per second stops in 5 seconds once the brakes are applied. What's the magnitude of the average force applied by the brakes? So here final velocity is 0, initial velocity is 25, time is given to us, so acceleration is v minus u over t. Acceleration is 0 minus 25 over 5, and this will be negative 5 meter per second squared. What's the magnitude of the average force? Average force is equal to mass times acceleration. So the mass is 1200 kilograms. Acceleration is negative 5. So if you multiply it, you get 60. You get negative 60,000. But since we want the magnitude, so the answer will be just 60,000. The answer would be 6,000, not 60,000, because 5 times 12 times 1200 is 6000. So the answer is 6000. Now next question. What would the net force acting on the car be if it moves uniformly? In this case, net force would be 0. Uniformly means net force is 0. Question 15. The gravitational force between two masses are d meters apart uh, is F newtons. Choose the correct answer to complete the statement below. If the distance between the objects becomes 2d, the force between the masses would be. If the distance increases, the force would be. If distance becomes twice, the force would be 1/4. According to Newton's law of gravitation, force is inversely proportional to the square of distance. A block of mass 10 kg is projected along a rough horizontal floor at an initial speed of 10 meters per second. The block stops in 5 seconds. Use g equal 10. The acceleration of the block is what? So first step, we have to find acceleration. Acceleration is equal to v minus u over t. Acceleration is equal to final velocity is 0, it stops. Initial velocity is 10. The time 5 seconds. So this is negative 2 meter per second squared. So the acceleration is negative 2 meter per second squared. The normal reaction on the block is equal to the weight, and the weight here is mg. 10 times 10 is 100, so it's 100. The magnitude of the friction on the block. To find the friction, we can say force is equal to mass times acceleration. Mass is given as 10. Acceleration, we found it to be negative 2, so negative 20. That is friction. Why negative? Because it's opposite to the motion. But since we want only the magnitude, so we write here without a sign, without the sign, so we write it 20, just 20. Next question, number 17. A bucket of mass 2 kilograms is being lifted vertically by a rope. The bucket accelerates at rate 1 meter per second squared. The weight of the bucket is W is equal to mg. So just multiply W equal mg 2 times 10, which is 20. So here you have 20. The tension in the rope. The motion is upward. This is the free body diagram. The motion is upward. The tension is up. The weight is down. Since it's accelerating upward, this means tension is greater than weight. So tension minus weight, that's the resultant force, is equal to mass times acceleration. Tension, we don't know it. Tension is equal to W plus MA, which means mg plus MA. So just multiply now mass, which is 2 times 10 plus the acceleration is given as 1. So 2 times 1. So we have 20 plus 2, 22. So the tension is 22 newtons. Now question number 18. A block of mass 1 kilogram is pulled along a smooth horizontal surface using a rope. The rope makes an angle 30 with the horizontal. The tension in the rope is 10 newtons. Fill in the blanks. The horizontal acceleration of the block to 1 decimal place is. So the free body diagram of the block, this is the block. It's being pulled by a force at an angle 30. So here 30, and the force is 10 newtons. The mass is 1 kilogram, so here you have W is 10 newtons, and normal reaction is also 10 newtons. Normal reaction, we don't know it, sorry. So let's see. Normal is unknown, because here we have another force. So the normal reaction is N. We don't have it. So this is the free body diagram. Now we split the 10 Newton force into two components. The horizontal component is 10 cosine 30, and the vertical component is 10 sine 30. Okay, now we solve the problem. The horizontal acceleration of the block to one decimal place. So here we do force equal mass times acceleration. The pulling force in this case will be 10 cosine 30. After splitting into components, we have to deal only with these forces. We have to deal only with these forces. No need to this force now. We have to deal only with the components. Okay, so the component pulling horizontally is 10 cosine 30 times the acceleration we don't know. So now we replace 10 cosine 30 is equal to mass 1 kilogram times the acceleration. This means the acceleration is 10 cosine 30. So 10 times radical 2 over 2, that's the acceleration. 5 radical 2. So acceleration is 5 radical 2. Since this is an accurate answer, but since they want the answer one decimal place, so convert this into decimal and put it here in the answer space. The weight of the block, W equal mg, this is very easy. You multiply 1 by 10, you get 10 newtons. Normal reaction on the block, we have to use the free body diagram. You can see that from the figure, W is downward force. It's equal to normal force, we don't have it, plus the vertical component of the force, which is 10 sine 30. So W we have it here, which is 10. Normal we don't have it, plus 10 sine 30 on the calculator, you get 5. So normal is unknown. 5 plus 5 equal 10, so here 5 newtons. Now question number 19. The diagrams below show 3 cases in which 1 or 2 forces act on an object, mass 0.20 kilograms. The object moves over a frictionless surface along the x-axis. The forces F1 and F2 are directed along the axis and have magnitude 4 and 2 newtons. So F1 is 4 and F2 is 2 newtons. So here you have 2 newtons, and here you have 2 newtons, and here you have 4, and F3 is directed at an angle 60. So here you have the angle 60, and F3 is 1 newton. Now take the positive direction to be towards the right. Determine the acceleration of the object in each case. First case is very easy. Force is equal to mass times acceleration. F1 is given as 4. The mass is 0.20 for all of them. 0.20 times acceleration. So acceleration will be 4 divided by 0.20, which is 20. So here 20 meter per second. For the second one, resultant force is 2. So 2 is equal to mass 0.20 or 2 times acceleration. 2 divided by 0.2 is 10, so here it's 10. For the next one, last one, we draw two components for the force. First component is 1 cosine 60. The second component is 1 sine 60. For the acceleration now, we do resultant force. 2 minus 1 cosine 60 is equal to mass, which is 0.2 times acceleration, we don't have. Then we divide both sides by 0.2 here, 0.2 here. Cancel these, you get the acceleration. Question number 20. The diagram below shows three forces acting on an object. Select the diagram that correctly shows the direction in which the object accelerates. So to do that, here we notice that F3 is greater than F1. So these two must be subtracted and the resultant will be downward. And then we have F2 like this. Now the resultant of these forces will be the diagonal of the rectangle like this, which means option A is the correct answer. Now question number 21. Every two particles of matter in the universe attract each other with a force that is directly proportional to the product of their masses. So here masses, and inversely proportional to the square of the distance between them. Number 22. Mass X and mass Y are placed at a distance r from each other. Determine how the force of gravity F between the two masses is affected in each of the situations below. So remember the formula for Newton's law of universal law, Newton's law. So G mass 1 times mass 2 divided by the square of distance between them. Now here we're telling you that the distance r is doubled. If the distance r is doubled, the force will be decreased by 4 times. So it's quartered. Both masses are doubled. If both masses are doubled, the force will be quadrupled. It will multiply by a factor of 4. So quadrupled. Both masses are doubled and the distance is doubled. So if both masses are doubled, which means the new force F prime would be G 2m1 times 2m2, and also the distance is doubled, so 2r squared. You notice that we have a factor of 4 up and down. These are cancelled, so there is no change. So here we choose constant, or no change, remains unchanged. Like this we finished. Thank you very much indeed. Don't forget to subscribe to my channel, and I hope to see you in another video. Thank you very much indeed.